Hello and welcome. I'd like to go over a couple of ideas as we get started here. One, the goal of this video is to help you understand the resources of Envision Mathematics to help you teach in a distance learning environment. I do want to put in a little disclaimer. We know there are many different types of distance learning. We only hope to provide some suggestions and ideas around Envision Math to help you help students. I want to thank you for things that you're doing every single day to help students in these challenging times. I'd also like to provide a little common language for the purposes of this video by defining synchronous learning as something that happens in real time and live. Asynchronous learning, students are learning at different times. We certainly hope that by the end of this, you'll understand how problem-based learning is meant to help students connect to the mathematics, to make them curious and engage, to meet them where they're at, to relate to their lives. So when they move on to asynchronous learning, they have an improved mindset and motivation to work through the problems. So let's see what this looks like in a classroom.
Okay, we are going to go ahead and get started. It looks like we're all logged in, we're all on mute. I am going to unmute several of you throughout our time together today. And of course, you'll be unmuted in your small groups in a few minutes when you guys meet to talk about those additional examples that we'll be looking at today. But I want to direct your attention again to this problem that we looked at yesterday, that I introduced yesterday before you had some time to work at home. Elizabeth wrote the following clues. What is the relationship between the shapes? So remember, today we're working on kind of those two-step equations. And I want you to think back to 6th grade when you were starting to work with those one-step equations, and we used that pan balance so that we could really visualize it and really see, how that affected the equation. And then yesterday when we reviewed our work, we were really talking about how to create those two-step equations. So we came up with algebraic equations, algebraic expressions for the two different students that had their different golf ball collections. Remember, you made different equations for that, and we got to take a look at those different equations. So again, last night you had the task of talking through this problem with someone else in your house or with a peer from our class, and really using those properties of equality to kind of reason about these different equations. So I want to take a look and share some of the work that was shared with me last night and this morning, so that we can go through it and look for things that you notice, things that you wonder, and have those students really have a chance to share with us what they did. So the first student that we are going to take a look at is Elijah's work. Let's go ahead and pull up Elijah's work. Looks like Elijah submitted work right here within the Realize platform. So let's take a look at what Elijah submitted. Okay, and Elijah has this fantastic visual. I just want you to take a moment to kind of look at this visual before we allow Elijah to explain. And as you're looking at the visual, I want you to type into the question box over there on the right, things that you notice and things that you wonder. So maybe questions that you have for Elijah. What do you notice about looks like Elijah's done some crossing off and kind of rewritten some of those equations. So what do you notice and what do you wonder? Okay, great. So why do you have two equal signs in the last equation? What does that mean? All right, let's go ahead and have Elijah unmute. Elijah, I want you to talk through, tell us what you did, and then let's talk through some of these questions. And actually, some of these questions I want us to answer in our small groups later when we're working through those stepped out examples too. Okay, great. Sounds like we had some fantastic discussion going on. Let's go ahead and pull up another student's work. And now I want to take a look at Hideki's work. So Hideki's down here. Looks like Hideki did an attachment for the work that she submitted. Okay, so let's take a look for a moment at some of the things that Hideki turned in. And Hideki, I'm actually going to have you unmute and talk us through kind of your rationale, step by step. How did you solve these problems? Why did you choose to solve it this way? What do each one of these shapes and equations represent? Okay, great. That's a fantastic explanation, Hideki. Thank you so much. It sounds like you really relied heavily on the subtraction property of equality when you were solving this equation. I want you guys to think about what you noticed as far as how that related to the last one that we had a chance to look at. What did you notice that was similar to Elijah's work? And let's go ahead and take a look at another student's work. And this time I want to bring up Ty's work. So here we go. Let's take a look at Ty did another attachment. Remember, you have lots of different options when you're turning in work, which is kind of nice. Lots of you like to change it up from day to day. Okay, so here is Ty's work. And before I have Ty unmute, I really want you to think about What do you notice that's similar between Ty's work and Hadiki's work and Elijah's work? And what do you notice that's different? Okay, Ty, I'm gonna have you unmute, kind of talk us through what you did. Okay, Ty, thank you so much for sharing. It sounds like you really relied heavily on variables and assigning different variables to the work, and it really made it easier for you to simplify and work through the problem that way. All right, so now that we've had a chance to look at the three different solutions, so now I want you to take a moment either on your computer or on the paper or the student book that you have in front of you, and I want you to write down which model do you think you had the greatest connection to? Either which one represented what you did and what you turned in yourself last night or this morning, or which one do you want to try to use in the future because it really made that connection and really cemented that understanding for you, and now you want to apply it later in this lesson. So take a moment, jot that down, and I am going to pull up that visual learning animation. All right, so remember, as we get ready to play this, we're really coming from that mindset of working through two-step equations. So using the variables and working through two-step equations to be able to help us solve. All right, get ready to share your thinking as we play through this so we can have that great discussion before we look at some additional examples.
Nala and her two friends spent $21 on movie tickets and a box of popcorn. The popcorn cost $6. How could they figure out how much each movie ticket costs? You can use multiple properties of equality until you isolate the variable.
Okay, so great discussions. I really appreciate you all bringing your different ideas to the table and really talking about how we can isolate those variables to help solve these equations. Let's go ahead and break up into our small groups, and we are going to work through those additional examples. And then once you guys work through those additional examples, again, I'll be entering each one of the groups separately, see how that discussion's going, see if I can help facilitate that discussion. And then I want you to work through your Math Excel problems that I've assigned to you. Again, remember to use those help tools to be able to help you solve the different equations. Or feel free to reach out and work with a buddy. Since you'll have different numbers, you can really talk about how you solved each problem and help each other out.